Hey guys, you are going to have your test this week. So we're just reviewing for your upcoming test. So hopefully you guys could print these problems and do them along with me. All right, so the very first question asks, what is the rate of change according to this graph? And what is the initial elevation? So first of all, let's do the first one. So if we took these points and thought about them as like a T-chart, if this is our x-axis, when x is 1, y is 15. When x is 2, y is 30. When x is 3, y is 45. So we want to know what is the change, right? What is our change in y divided by our change in x? Where our change in y is 30 minus 15. Our change in x is 2 minus 1. So 30 minus 15 is 15, 2 minus 1 is 1, and 15 divided by 1 is 15. All right, so that's our rate of change, also called our slope. And our initial value, so basically the initial value is the y-intercept. So I should have written the original origin for our t-chart here, because if you notice, the line touches the origin, which is 0, 0, right? So your y-intercept is your initial value. So when x is 0, y in this case is also 0, which means that our initial elevation was 0 feet. So at 0 seconds, the height of elevator above the ground was 0. So your y-intercept and your initial value is always the same. All right, so let's look at this one. We have a table and a graph here. So it wants to know what is the rate of change for both the table and the graph. So first of all, we see that these x values are increasing by 1, right? These y's are increasing by y. So if we want to find the rate of change, we're going to think, what is the change in y over the change in x? So the change in y is 100 minus 80 is 20. The change in x is 5 minus 4, which is 1. So the rate of change on number 1 is 20, or the slope is 20. Now, if we wanted to figure out what the equation of the line is, we could figure out what y is when x is 0. So since these numbers are increasing by 1, we could go back to 3, 2, 1, 0 if we added these to our t-chart, and then we continue the pattern. So going from bottom to top, these are decreasing by 20, minus 20, minus 20, so minus 20, minus 20, minus 20. And once again, we would find out that our y-intercept is 0, just like on the very first graph. But anyway, the question for number 3 was the slope, or the rate of change for the table, is 20. Now, this graph right here, we have when x is 2, y is 70. When x is 4, y is 140. So what is our change in y over our change in x? So 20 minus 70 is 70. And 4 minus 2 is 2. So half of 70 is 35. So our slope for the first one is 20, and for the second one is 35. And also, they both have this in common. They both go through the origin, right? So they're both considered proportional relationships. This is going up for every one x value is going up by 35. For every one x value over here, for every one x value is going up by 20. So then the question is, so since we know our slope and we know that y-intercepts are 0, how much more would y be on the graph than on the table when x equals 12? Well, we know that these keep increasing by 35, 35. So when x is 10, y would be 350. And then when x is, so basically this equation right here is y equals 35x plus 0. And this is y equals 20x plus 0. So if we just plugged in a 12 right here, well, 35 times 12 is, whatever that is, 35 times 12 is 420. And here, if I plugged in a 12 for X, I would get, let's see, 240. So how much more would it be on the graph than the table? So it'd be 420 minus 240. And it would be, the answer is 180 more. 180 more. All right, makes sense? I hope so. All right, moving on. So find the unit rate for the graph and table. Again, the unit rate is the slope, okay? So we do know that this one starts out at 0, 0. We're not sure about this one until we find the rate of change. So as X increases by 5 here, X is increasing by 5, right? 5, then 10, 5, then 10. What is happening to Y? So when X is 5, Y is 20. When X is 10, Y is 40. So what's our change in Y over our change in X? Well, 20 over 5 would be 4. So every time X goes up by 1, Y goes up by 4. So in other words, the price of sweetbreads, they're $4 each. We start out, if you don't buy any sweetbread, you pay $0. Well, what is happening here? Well, the change in Y is it's going up by what, 45? And the change in X, 10 minus 5 is 5. So 45 divided by 5 is 9. And both of these would have 0, 0, a y-intercept of 0. If you buy 0 shortcakes, you pay $0, right? That makes sense. So here our equation is y equals 4x, and here it's y equals 9x. So the rate of change is 4 and 9. And since these are proportional, since they go through 0, 0, you could just divide the y by the x and get the unit price. Write the equation of the line. Well, the first thing we want to do is figure out what our y-intercept is. So equations are written in y equals mx plus b. B is your y-intercept. Where does it intersect the y-axis? And your m is your slope. Oops. Slope, and remember we always write slope as rise over run. So we know our y-intercept is 0. Now we want to find 2 places where it goes through. We could use this point and 0, 0. We could use this point and 0, 0. Either way, we would get 1 over 1 or 2 over 2, which is 1. And so our rise is 1, our run is 1. So we multiply x by 1 over 1. Our y-intercept is 0. Now, the last thing I need to do is think, okay, does my line go up and to the right? Or does it go down and to the right? And of course, it goes down and to the right. So the slope is negative. So 1 times x is x. So the best answer would be negative x. We don't have to write plus 0 ever, do we? So that is the equation of the line. If our line crossed up here at 6, I would write plus 6. If the line was shifted down here to minus 8, the end of my equation would say minus 8. But since it goes through the origin, the y-intercept is 0. What is the initial value of the equation shown? So remember I told you that initial value is the same as the y-intercept. So in an equation, it's always easy to find the slope because it's the number multiplied by x. The number that is not multiplied by x is the y-intercept. So make sure you just don't think it's 5, it's minus 5. The initial value is minus 5, which is the same thing as the x-intercept. No, it isn't y-intercept. When x is 0, y is negative 5. All right, number 8, what is the initial value of the function represented by this graph? Well, when x is 0, here, when x is 0, what is y? Y is 5. So this one's positive 5. And then every time X increases by 1, Y decreases by 1, right? So if it asks for our equation, we would do our rise over run is 1 over 1, negative 1 over 1, X plus 5, because that's our Y value, our Y intercept. So negative 1 times X is negative X plus 5. So it didn't ask for the equation of the line, but it's always, you know, it's good to practice figuring that out when you have an opportunity to. Number 9, I'm going to erase this. What is the equation that is portrayed by the graph? All right, so the first thing we always want to do is figure out what our y-intercept is. The y-intercept is what y is when x is 0. So we already know our y-intercept is positive 3. So now we want to know what is the change in y over the change in x. That's what I'm doing. I'm kind of doing this part in my head, right? x2 minus y2 minus y1 over x2 minus x1. So our second y value, it doesn't matter which one you use. It doesn't matter as long as your x1 and your y1 are on the same line. All right, so we're going to do 13 minus 8 over x2 is 2 minus 1. So 13 minus 8 is 5. 2 minus 1 is 1. So our equation is, our slope is 5. Rate of change is 5. And we always write our equation y equals mx, our slope times x, and then plus our y-intercept, and our y-intercept is positive 3. So that is the equation of this table. All right, which equation best models the relationship between x and y? So before we look at our multiple choices, let's look at our graph. So first thing I want to do is figure out what is the y-intercept. What is y when x is 0? When x is 0, y is 250. So that's our y-intercept, positive 250. And then I can figure out what the slope is by doing rise over run, but be careful, this isn't 1 over 1. This changes by 50. So our rise is 50, and our runs from 0 to 1, that is positive 1. So our rise is 50, our run is 1. Is it going up to the right or down to the right? Since it's going down to the right, it's actually negative 50. So our slope is negative 50 times x, and we know that our y-intercept when x is 0, y is positive 250. So, but before I even look at the multiple choices, I know what the answer is. Oh, it didn't even give me multiple. Oh, it didn't give me multiple choices. I took those away. So anyway, we know what the answer is anyway. Negative 50x plus 250. All right, I'm going to need to erase these so we can see the next problem. What is the fixed amount charge? So basically that means the fixed amount. So what is the constant rate of change, right? So the first thing, well, you know what? The fixed amount charge, no matter how many days you rent equipment, you have to pay $25. So notice that the rate per day looks like it's plus 15, plus 15, plus 15, plus 15. So the rate of change is going to be 15x. But when x is 0, y is 25, which means no matter how many days you rent, that fixed amount that you're charged is always $25. So in this situation, the y-intercept, which is positive 25, is going to be your fixed amount charged. And then you have a rate per day. Does that make sense? Because even if you ran it 2 days, you're going to pay $15 times 2, which is 30, but then everyone pays the $25 fixed amount. So 25 is the answer on that one. All right, what did that say on the top? Distance. Oh, based on the graph, what is the initial value of the graph and what does it represent? So this is the distance from a nest. So maybe we're talking about a bird. And this is how much time goes by. So whenever someone started timing this bird, we'll assume it's a bird, when they started their timer, the bird was already 3 miles from the nest. So the initial value when X is 0, Y is 3. The initial value was 3, and this represents miles, 3 miles. And what does it represent? The beginning distance from the nest is 3 miles. And then it looks like for every 5 minutes that someone is timing this bird, it's going another mile farther from the nest. So maybe a baby bird was learning how to fly, I don't know. Whatever the situation is, okay? But the initial value is when X is 0. All right, number 13, which graph represents a decreasing value? So we always read lines from left to right. It's either going up, it's going down, or it's going constant, right? So the decreasing value, which one's going down? That one is it. Very good. What about an increasing function? Increasing function would be letter B, right? What if my question was which one shows a constant function? That would be letter A, and that's a vertical line. All right, number 14, identify the slope and the y-intercept of each equation. So our slope, m, is always the number multiplied by x. So this one is 8. Our y-intercept is +4. Letter B, what number is being multiplied by x? What is our slope? Our slope is -1/2. And our y-intercept is -5. And then look at C. We talked about this several times. Lines that go up and to the right and down and to the right have an X and a Y in the equation. And then we talked about Buck's Hoy, correct? So this means a vertical line has an undefined slope and only an X is in the equation. So I know that there's not an X in this equation at all. So I know this is not a vertical line. However, I do see only a Y in the equation, which tells me that this is a horizontal line. So horizontal lines have a slope of 0. The slope is 0. And if I graphed it, let's say I went to where y equals 6 on the y-axis, so it'd be 1, 2, 3, 4, 5, 6, about right there. I'd put a horizontal line. And the question is, what is the y-axis? Where does it cross? Where does it cross the y-axis? The y-axis is 6. The slope is 0. Because this tells me it's 0. Horizontal lines have a slope of 0, and my y-intercept, it crosses my y-axis at 6. Okay, so that one's a little tricky. And then let's see, I lost my mouse. Here we go. The next one says the distance y in miles traveled by a car for a certain amount of time, x in hours, is shown on the graph below. So we started our time at 0 and our distance from our starting point at 0. This is where we started. In 1 hour, we were 13 miles from our starting point. 2 hours, we were 26 miles. And then for the next hour, even though the time continued, our distance from the starting point did not continue. It was constant. And then for the next 3 hours, we traveled at a rate of 13 miles per hour. You see that? So let's basically read these and see which one that says what we just said. It travels for 3 hours, it travels for 2 hours, then stops for 3 hours. It doesn't stop for 3 hours. It only stops for 1 hour. So I can automatically say, well, I know A and B are not the right answer. It doesn't stop for 3 hours. It stops for 1 hour. So both of these agree. And then finally travels again for 5 hours. So from 3 to 5, is that 5 hours? We don't know what happens after hour 5. So from 3 to 5, that's 2 hours, right? So D is the best answer. All right, you guys, that's it. So hopefully you guys could do those on your own, and then hopefully you watch the video just to check your answers. That'd be awesome. And now you're ready for your test. So we will meet for just a few minutes tomorrow. I just want to know what or this week, the day before the test. So that'd be Wednesday. Just to see if you have any questions. Is there anything I can explain to you? What have you struggled with this unit? And then you guys will take your test on Thursday. Friday of this week will be a makeup day. No zeros, no zeros. All right, guys, have a great week, and I will talk to you guys soon.